Four essential components of power plant maintenance. Power plant maintenance aims at supporting a smooth workflow in a power plant. It involves procedures such as routine inspection, equipment and adjustment, repair or replacement, and general systems integration and monitoring. If you work in a power plant, you recognize the significance of all the plant's assets, big or small, in ensuring that the primary goal of electric production is realized. For this reason, you should implement maintenance strategies that compromise most of the requisite components. So, what are the essential components of power plant maintenance? Read below to learn more. 1. Computerized Maintenance Management System CMMS. As a power plant comprises many components, it's difficult for you to single-handedly oversee their maintenance, more so if you are doing so manually. On this account, you may bring computer systems into play. A computerized maintenance management system comprises software whose main function is to oversee the maintenance operation in a facility. A perk of CMMS is that it can be customized to meet the needs of any industry, including the power production industry. You can therefore source power plant related CMMS like the Power Plant Asset Management Software Solution by 60Hz Energy to run the maintenance process in your power station. One of the strengths of the software is its inbuilt database system, which is responsible for organizing information about the assets in the station that require maintenance. It also offers learning resources and standard procedures to conduct maintenance. Being computerized, CMMSs are significantly efficient. Thus, they are an essential tool you can use to run maintenance operations in your power plant. Number 2, predictive maintenance PDM tools. These are tools that use the Internet of Things predictive technology to manage assets by monitoring their condition and assessing their reliability. This way, it makes the use of already existing assets more efficient. Through predictive maintenance tools, you can carry out a predictive test to the machines in your plant, determine the possibility of their failure, and formulate a plan to handle the issue if it arises. In the long run, PDM tools significantly reduce the general costs of power plant maintenance. They are wired to software such as CMMS, wherein they report the finding of the assets analysis. A bonus of PDM tools is that they continuously report their findings. Hence, the CMMS can quickly spot the assets that require maintenance and schedule the repair. The main PDM tools include vibration analysis (VA). This analysis tool uses sensors to detect an asset's vibration velocity, displacement, and frequency. These parameters are then measured alongside standard vibration signals, and the outcome will determine whether the specific component requires maintenance or not. Ultrasonic analysis UA. This tool uses a sensitive microphone to capture high frequency sounds from an asset. It then turns these sounds into audio and digital data that can be analyzed by the human plant operator or computer software. The analysis is done by comparing the sounds to other existing known sounds that indicate a problem in an asset. The analysis results will then determine if the asset in question requires maintenance. Infrared IR analysis. This technique uses infrared technology to compare the temperature difference in assets over time and under different conditions. The difference indicates the state of an asset and whether it needs maintenance. IR is used to provide information such as temperature changes in mechanical assets like bearings, the system's temperature, isolation conditions, and solar panel conditions, among others. Oil analysis. The purity condition of the lubricating oil is analyzed to determine its suitability in the protection of equipment from wear. Laser shaft alignment. This analysis technique ensures that the various types of equipment in a power plant are properly aligned to prevent component mechanical failure. Motor-circuit analysis. This technique uses electronic signature analysis (ESA) to identify potential faults in electric motors and their components in the power plant by assessing the asset's voltage and operating current. Video analysis. This technique captures equipment vibrations on video. The vibrations indicate whether a maintenance procedure is needed for an asset. Therefore, if you run a power plant, you can incorporate the predictive maintenance tools in your operations to have an outlay of how your equipment is functioning. PDM will also give you a heads up in case there is any faulty equipment that needs to undergo maintenance and repair, thereby minimizing production losses and unnecessary disruptions. Number 3, supervisory control and data acquisition systems, SCADA. There are centralized industrial control systems that use computers and network data communication to monitor plant and machinery conditions. The systems gather data on the processes in the plant and send the commands control to the process. They are used where human control isn't a feasible option. Some applications of SCADA in power plant maintenance include constant monitoring of speed of electrical machines, monitoring of coal delivery and water treatment processes, planning of electric generation operations, controlling active and reactive power, monitoring renewable energy farms, load planning and scheduling, processing of generation parameter data, and supervising safety equipment. Number 4, human input. The above three components of power plant maintenance are based on computer systems. Even though the computerized systems ensure efficiency in the maintenance process, human input is also required to realize an all-encompassing maintenance process. For this reason, power plant workers, including plant operators, power distributors, and power dispatchers, are needed to manually control the systems. Some of these duties include formulating maintenance procedures, scheduling maintenance processes, diagnosing and responding to system malfunctions, supervising staff, obtaining specialist equipment such as fixtures, bearings, and fittings, handling stocks of supplies and equipment, controlling budgets, keeping and maintaining statistical and financial records, and ensuring that health and safety measures are adhered to. Conclusion: if you are a maintenance engineer at a power plant, you should ensure that the equipment is properly functioning so that the power production process runs smoothly. To do this, you would want to combine all the essential components of power plant maintenance. These include computerized management maintenance systems, predictive maintenance tools, supervisory control and data acquisition systems, and your effort to oversee the smooth running of all the systems.